at night on my bonus channel, where we are going to look at some wacky graphs I have been experimenting with. And let me pull open our graphing stuff, which will be done on the free website graphing calculator thing, Desmos. And today I'm also going to explain for my frequent recurring viewers some details about things I've been busy with and some reasons like why I haven't live streamed much recently and some other upcoming plans that will be going on my channels. But here what we have to begin, so that we have our graphs going on first, is what I'm calling symmetrical-ish graphs. Now, the symmetrical-ish, what I mean by that, is here, for example, there are two ways that symmetry of purely the same thing being on each side of an equation has been altered. We have the y and the x. I swapped which one comes after the sign and which one comes before. This one has the y first, this one has the x first. And we also have a coefficient that's a bit different on each. And first, let's see what happens when we set these coefficients to variables, so we can see with different ratios of offness of our symmetry. Here we can see quite a bit of symmetry in some different ways. And one way, for example, is it appears at least rotationally symmetrical, where I believe if we rotated one of these quadrants, it would line up with that. It's not quite a mirror image, but it's also like we had a mirror image with the colors swapped. So we could get that with a sort of double mirror image. So there's a few symmetries at play here when they're both just equal to 1. And I think this is a underrated, pretty cool graph here, because we have, when there's 1, that's the same as these variables not even existing. And that's a pretty simple graph as far as, or a pretty simple equation as far as all the coolness we can find in here. If we look up in this quadrant, for example, when we're too far zoomed out, we're going to see some strange things like glitches. There were some interesting ones I was playing around with before the stream where the glitches themselves can be quite interesting, but we have to remember that, for one, whenever it displays this warning, we should be warned that some things may be a little off. And for two, if I ever move it around and we see things shimmer, that's sort of giving me the clue between all of the shimmers what's really there. And some of the spots of shimmer only show part of what's there. And so here, if we zoom in a bit, we can see a little more clearly what's going on in particular regions. Here we can see no shimmers, no warning. And then zooming out, we can see the bigger scale to a degree. And one thing that I already found quite interesting was when we only had the semi-symmetry, which I didn't call the stream here semi-symmetrical graphs, although that would have fit quite well. It had a bit more alliteration than symmetrical-ish graphs. However, there is a thing called a semi-symmetric graph, and it's not this type of graph. Sometimes I discuss what's called graph theory, which is a totally different type of graph than a coordinate plane graph. So there's an unrelated-ish concept. All math things can be connected, but unrelated to a degree concept called a semi-symmetric graph. So I'm not nicknaming this semi-symmetrical graphs. That's too close. And that sort of hints that the graphs themselves will always be close to symmetrical. And I'm not sure if that will always be the case, because what we have control over here is the equations. And those are the things that we can play around with different forms of almost symmetry and see to what degree graphs sometimes maybe eat up the almost parts and look really symmetrical, or sometimes maybe the almost part outweighs the symmetrical-ish part and it doesn't look that symmetrical. And sometimes it might depend on a ratio we have between some things we can play around with. We can even see them animated and moving, although right now it's not doing anything because I removed it. But here, this, as I said, is a pretty neat, underrated graph, in my opinion. I'm going to have a long, hard think sometime about why does this result in this? Because with some of the graphs I play around with here, they're so complicated with the amount of stuff thrown in the equation to make a really magnificent landscape here. But then it's a lot harder to do the, tracking back and forth mathematically if we were curious about why exactly it does look a certain way, as opposed to just seeking cool shapes, which has its own value. And here, this is one that's simple enough that I think I could think through it. So I'm going to try and, digest this one a bit sometime. But as we complicate things a little bit, the first thing I tried that was part of what made me think, well, I've been wanting to do a live stream anyway to chat about a few notable things going on in my world and upcoming and previous and so on my channels. But also, I always, when I'm not sure what to have as a sort of stream activity, while I also want to just make some form of content, I have a backlog of notes about many things, but many of the notes I had often been applying to live streams. Let's see. Here, yeah, I just have A the same. So I'm going to actually keep it here centered for a moment. And let's give a little more room to the graph. So I have a backlog of notes about all sorts of stuff, especially when I don't release as much content in a given week. The backlog just grows in terms of notes, because those are the things that I always spend time generating. But some of those notes I had often been putting into live streams, and the YouTube just doesn't show my live streams to as many people as other forms of content. So a lot of the ideas make more sense for me to put out as like a bonus video where they'll reach more eyes. However, with the live streams, certain things are more experimental and exploratory, where I have a seed of an idea that I still want to test. And for example, a few families of graphs I'd like to show and then edit in an experimental improvisational way. And so graphs are a recurring thing that I do like to do live, whether or not YouTube shows it to that many people. And some of the other projects, here is a time where I'll note before we make B different here, because this already is so cool for a simple graph. Look at that sliding in and adding layers. Let's look at it at a few different scales. Actually, let's just put the animator on for a second, but let's make the speed slower. How do I do that? Where's this stuff about the speed? Yeah. So really slow. Oh, I didn't even know we had multiple modes. Okay, so loop forward and backward sounds like a good default. That's a good thing that was the default, because I didn't know there were options. So while we look at this from a few different scales for 1 second to look at this simple graph, because this is just when they're the same. The only different, so it's quite symmetrical in a way, but there are things that have their colors flipped, and just the way it morphs and emerges is quite interesting. Also, if you look at where the dots emerge from, it's interesting. Some of them seem to emerge, these things coming out from grid points that are like integer coordinates. Other ones don't. The other ones seem to come out of weirder spots. So we'd have to look pretty close maybe and really slow to maybe see exactly where these emerge from. But I also figured it was a good time to note some of the projects that I've been working on are just my own form of content that is partially finished. Others of them I have been working with more programmers, and I've been using the combo class Discord server more often, which I'm not a big technology guy, so I still don't fully understand Discord. I hadn't used it really before that. But that is a place where if you want to chat with other combo lords, you could. But also, I have a side server right there where I'm just working with a few people, a private group, to help me program some ideas and stuff. If anyone who isn't like part of the Discord world, but would want to maybe join a group of combo collaborators on helping me with some technological sides of some of my personal ideas that require things like coding or animations or things that instead of spending all the time learning how to do them, I would rather focus on my skill set, which is ideas as opposed to all the technological sides. Let me know if you would have any interest in something like that. If you don't have Discord, you can also email me, and I'm finally catching up on some of those. But there's been a lot of crazy personal stuff in my life. Not as far as some personal issues I've discussed before, like my legs and other issues and things are, my personal issues like that are okay. However, there's some issues with my family and stuff that have gone on, and maybe I'll give more details about those later in the live stream. But in any case, just know that my life can be complicated, and there's a lot of crazy stuff going on in the world as well. So it hasn't been the busiest release schedule for me, but as I said, I continue to generate notes throughout that time. So there's a lot of cool stuff coming. I have come up with a lot of interesting patterns. And now let's change these to something like secants for a moment, because while it was cool to go through different stages of that one, I want to show a few others of a family. And what we're going to do... Oh, I changed both to B. I was being silly. I was defaulting. I changed both, so then sort of the same as when I had both set to A. Here they're different, but let's put them back to A for a moment while we look at a few other types of graph. And to anybody in the chat, thank you for chatting. I will check the chat and reply to any comments or questions anyone has, but I'll check it in a moment. For now, I wanted to show a few other examples of this family right here, where by family, I mean I had all of these set to sine, and it was a pretty simple equation. It's sine times some constant that we have on a slider times y, it was sine, x is greater than or equal to the exact same thing, but with x and y flipped. That's the only way this one has the symmetry broken. So here, when I had sine, we had one family scrolling through, but this is the secant family that's quite different. And here we're at the scale where you can't quite see everything that's going on. But when you're really zoomed out, it kind of looks like trying to look at like a universe or something from afar. And it's like your telescope didn't get that part right. You can see a lot of things that resemble things in some graphs here. One of the ones I was playing around with earlier really looked like eyes. Maybe I'll pull that one back up. And this one has a sort of optical illusion where it looks quite spherical. And we do have some other suggestions of graphs in the comments. I will certainly try those after I try this family. And oh, whoa, that's a big mosquito. So if you see me clapping at anything aggressively, it's a mosquito. One of the only animals I dislike. And this one is pretty neat. Look at the way this one folds in and out of itself with these circular-like things that also become square-like things when they're at particular angles. So, yeah, that is wacky. We have all sorts of circular things and all sorts of, almost like square things merging together and becoming each other. And then we zoom out a bit and we're like, whoa, there's a ton of different states of this. Now, when we're zoomed out, recall this dust is not describing it clearly. However, these parts we can see pretty clearly, so it's still useful to see it zoomed out, what it's able to show us. There's always limits to what we're going to be able to see with a graph with our human eyes and what with the graphing calculator can properly display. Partially, it can be not just the limitations of the software, but also that sometimes it's too crowded to show. Like right here, it's too crowded. It would just be like a big black blob there if they made every spot that occurs have a whole line. So they have to, be careful with when they put the lines or not to actually give it a shape. And speaking of shapes, this has one of those optical illusions where it definitely looks curved. You see that curve right there? That's wild. Here, it looks sort of like you're falling into a tunnel. But, oh, that's just one little tunnel. There's a lot of different tunnels you can fall in this landscape. So this is the secant version of that family. And one more time up close where we'll get the non-dusty view of it. How close? I guess we have to go really close to lose all the dust. Might not even be interesting at that scale. Still got a little dust in the corners. But still looks pretty neat. And, you know, A is on a pretty small scale right there. Let's give it a little more wiggle room. Let's put it negative 100 to 100. So now we can see, whoa, other patterns forming. Okay, when I go enough that we can see it right, but where there's a bunch of them, that looks quite spherical when we get the right view of it. That looks like a, you know what this looks like? The Earth and its magnetic fields. This is like magnetic fields coming out of a planet. And this is like the cosmic radiation that the magnetic fields protect it from. And here, when we zoom in, may not look that interesting, but I love in its own way when it looks sort of boring like this. And if you looked really closely, you're like, wait a minute, this isn't just a grid-like thing. This is sort of curved. What's going on with that curve? And then if you went down here, you're like, whoa, even at the same scale, or you could achieve that by zooming out. Now, let's do one more member of the family before I look at some of the suggestions from the chat. And when I do different substitutions of a trig function, my three favorites to sort of show different sorts of family are sine, which is similar to cosine, tangent, which is quite different, and secant, which is sort of different than either of those. And while there are many trig functions, a lot of them are expressible in they're all expressible in terms of each other in some way or another, but some of them it's a really simple way they're expressible in terms of each other that makes them not look that different. And so, for example, sine and cosine look pretty similar when we put them in here. There are cases where it's way different, but a lot of the time, switching a sine for a cosine won't go as far as switching it for something like a tangent. Tangents explode sometimes, and we can sort of see a clue of how that would happen if we just look at like y equals sine of x, and we're like, okay, that looks pretty contained. It's flying off the sides, but up and down, you know, we're contained in a nice little range. Patterns that relate to pi is when it touches down and crosses the axis. But if I do tangent and if I do cosine of x, very similar, just slid over. If I do secant of x, it's a bit different, and tangent of x is a bit different. And we can see that secant and tangent sort of explode in different ways. Tangent like comes up from negative infinity and swoops around and goes up toward infinity. And here we can see that if I substitute tangent, for example, it's going to look a bit more like the secant one than the sine one, but also is going to often look even crazier. And this one's cool. This one really shows a shape that tells you, okay, there's sort of like 8 notable zones in a coordinate plane graph, because we have 4 quadrants, but there's something extra notable about the different sides of the line y equals x or the line y equals negative x that sort of split each of those in half. Here we have points, for example, where x is larger than y. Here we have points where y is larger than x. And certain things, I can only graph them a certain way, but I would only need to look in one of those zones and then like reflect it to see, oh, what if I had done x and y swapped? Sometimes you get all of the info from one of these slices. And with this graph, it sort of looks like we're getting all the info if we allowed ourselves to swap the colors from 1/8 of it. Otherwise, we're getting all the info from 1/4 of it if we don't allow swap the color as an operation. Which, remember, swap the color is the same as switch the direction of this. Although I put greater than or equal because it makes lines where it's exactly equal and makes it a lot clearer looking than it puts dotted lines there. If I just put this, doesn't look as clear, because like, what if those were actually dotted lines? Some of the things we graph, we need to know if the lines are dotted or not. So here, greater than or equal works a bit better, but if we swap it, we can see it's going to basically color shift it. What I also like about the inequalities is that if I set this to just equal, we lose so much depth. Look, we would almost be like, okay, that's sort of neat, does the thing about cutting it into 8 that I mentioned, move on. But then when I set it like this, it has more stuff going on. you couldn't see that these zigzag back and forth when you just have equality. There's a hidden thing there. It's invisible. Let me know if you have any prime examples you've found of that, because I've found so many cool graphs that I've never mentioned like in a main video of any sort, that were just like something I found on a live stream at some point. And so at some point I'm going to collect some of them based on certain types of graph. And one of the concepts that I want to collect the best examples of is times where equality does not show you all the stuff that inequality does, where there's more going on if you make it inequality. And we have a note in the chat. What I'm going to do here, for a moment, we're going back to sine, but we're going to set a different coefficient. This is going to be b, and that's going to be a. And this is interesting. We can see it's sort of boring when one of them is sine and the other is tangent. It's way more interesting when they were either all tangent or all sine. Or no, wait, what's going on? I messed up something here. Sine a... Oh, it's just because b is 0 maybe is why it was boring. And maybe because I was really zoomed in. Yeah, oh, yeah, it was just because a and b were too asymmetrical. I forgot, we're supposed to do symmetrical-ish. Symmetrical-ish would imply here that we're keeping a and b somewhere near each other, or maybe some other twist of similarness to each other, like maybe the negative version of each other. What happens when we do that? If I set like b is 5 and a is negative 5, that's another way we could create two numbers that are close. And that's, you know, an interesting philosophical question I have for you folks about numbers. In what ways do you think that the number, for example, the number 5, in what ways is it closer to 6? And in what ways is it closer to negative 5? Or perhaps 1/5 or 5i? Now, also, make sure you've seen my episode on my combo class channel about how in the main way of doing complex numbers, which relates to a comment I'm about to answer, the main way of doing complex numbers having integer grid points is called Gaussian integers. And if you allow those to have Gaussian primes that don't reduce and can't factor in the same way, you can look at Gaussian factorizations of numbers. And 5 is not as prime as some of the other primes if you allow the Gaussian integers. However, as a comment here from Sebast314 notes that I may like playing around with graphing complex functions with complex outputs. Well, the problem with that is that we have a 2D structure for an input and a 2D structure for an output. So I have yet to leave a suggestion if you have any particular graphing calculators you think do it well. But to actually fully view it, we would need a 4D graph to fully see here is an input to output, the similar way that I would have like y equals x squared. To fully see something like that, if this was like involved imaginary numbers, if it was like x plus xi or something, but not just squared, because that would, you know, simplify. But some cases involving imaginary numbers, we would sort of need a 4D graph because there's 2 dimensions for an input and 2 dimensions for an output. And so you can't graph things as complicated as what we're doing, because we're playing around with 2 variables and having x's and y's and stuff. But this is as complicated as just an input of complicated numbers is, because that is often described on a whole 2D plane like the complex numbers. So leave a comment if anyone has any suggestions of a good graphing calculator to achieve the closest attempt to that. But when I've done complex mode on Desmos, I haven't found anything quite as fun as this stuff. It will show up when I need to demonstrate some things for videos and things, but as far as finding cool landscapes, I found it much trickier due to it not actually being a full complex plane input-output graph. And we have a note from Sebas that you could have a 3D graph with a time parameter. So yeah, if you had a 3D graph that was evolving, but a 3D graph already you can't fully see as a human because the 3D graph's on a 2D screen. Unless we have a hologram that you can like look into, sort of, it's going to be hard to see a 3D thing. Even then, our eyes sort of see things in cross sections. We're good at adding depth, but especially on the computer here, even a 3D graph is hard for a human to see properly. And the best things you can see on a 3D graph are often when it's flat enough that you're almost seeing a 2D graph. But I will experiment more with the 3D graphs, and if you did have one evolving on a time parameter, there would be a way to make that a complex graph, although it would be pretty strange because two of the inputs would be spatial, and then, or either for input or output, but let's say input first. Two would be spatial, and the other would have one spatial and one like temporal. So that would be sort of weird, but it could work. But I'll do an episode sometime about the best ways to try to visualize higher dimensional graphs. The main note about that to note here is we are looking at a 3D graph in cross sections when I have one variable changing. Because right here, if this variable A that's changing was Z instead, these are cross sections of that graph. So we're looking at slices of a 3D graph right here. The benefit of some 3D graphs that I'll try around more is you could do your slices from a different angle. But you're still going to have to see slices if you're looking on a computer screen. And even if you're not, with the way the human eyes work, it's very hard to not see things of 3D just as cross-sections that we're good at adding depth to. And then comes 4D. But I'll explain more about visualizing the fourth dimension in the future. Here, what I wanted to show was when we have, I put it negative for a minute, but I wanted to show when they're close to each other. So when I have 1 and 2, now we are really at the semi or almost symmetrical-ish fashion, where not only do we have color swapped things going on, but these sides, for example, look really similar to each other. But are they the same? Well, if we go down a bit, let me find, we might need these a little further. I guess, is this the direction that got smushed off? It's certainly not as symmetrical as when they were the same. We can see here we have like more of a 4-way symmetry and almost an 8-way symmetry if we didn't have the colors swapped. Although, you know, we need the colors swapped to see colors here, but because we need half of it filled in for it to have a pattern looking like this. But I guess another option would have been if this one was directly a flip similarity of like symmetrical across an axis as opposed to rotationally. But here, when we put them a little off, whoa, quickly changes. So I need more precision. This one is on a way different scale, so it's flying away way quicker. We're putting them back to 10 and 10, but we're going to give them small steps. Okay, so here's when they're just a little off. We can see it quickly morphs. They were symmetrical, but now they get smushed a certain way when I move that. If I move this one, they move the other way. And if I get them equal, we get back to, although we did have a flip of symmetry here to make anything interesting happen at all, where the y and x were flipped, that's sort of the first flip of symmetry that creates a graph at all, because otherwise the two sides would be the same. Then here, when we change these a little, we lose all of the symmetry, but we could call this almost symmetrical-ish, because if I look at comparing some of these sides that are a bit different, we can see here versus here, for example. Maybe I need to get them a little further off. They're within 0.1 of each other. When I go a little further, let's see. There's still a lot of symmetry. This one may be sort of doing the thing I was mentioning where a lot of what's going on in the graph is still going to be symmetrical, where it sort of ate up the almost symmetrical part. We lost symmetry in some ways, but it's sort of almost like we changed. Before, it's like we had multiple types of symmetry going on at once. Now we, and some of the types of symmetry before were like a flip and a color swap, whereas others were like a rotate. And this all sort of relates to group theory, a very deep concept in math, but I'm not going to describe it in those terms right now. I'll do an intro to that someday. Here we can see that we have multiple symmetries that were going on, and we lost some of the symmetries. It no longer has a four-way rotational symmetry. However, it does still have some of the symmetries. It still has this one, could flip across that axis and have its colors swapped, or it could flip across this axis and have its colors swapped, and it could double flip over here without swapping colors. So there's a few different ways that we still do have symmetry going on, which the mostly symmetrical structure of the overall graph, I guess, sort of guarantees here. Now, does that still apply if these were the secants instead? So secant was a whole nother wacky realm, and now we are making it wackier by changing A and B separately. When A and B were together, it looked like this, which did have many levels of symmetry. And now, if we make this one shift a bit, we sort of smush it that way, but it's not just smushing. When we smush, we add new overlaps. And here we're sort of getting more stuff going on as we continue to smush and build overlaps. Some of them look sort of like, when you look closely, more in the sine one than this one, but some of them look sort of like bubbles forming. And then if you were looking through a mesh of many bubbles forming, you'd see more overlaps if they were fully translucent, but their outsides had like, some degree of shape you could see. This one less so than the sine one. This one looks more sort of like sprouting mutated chessboards, but then you zoom out and it looks totally different. So this one, let's put them back. Well, let's put them on sliders, but here's what we're going to do. Let's make them, this is a good way to start out symmetrical, get less symmetrical until we're like, okay, that's enough. We got too unsymmetrical. Here's how we're going to do it. We'll have them both go. I'll try and click them as close to, I was going to say start them at the same time, but I don't know how to do that. So I'll click them as close to each other as quickly as I can. But we'll put them at different speeds. So let's put them at, how can I get them like, what are the closest ratio of speeds here? They have different weird options for the speeds. Like they want one close to 1/3, I guess, so they have 0.35. And so, yeah, what's the ratio that's smallest between all these? I'm going to go with 1.5 to 2 for now. And that one will be on 0.15. That one will be on 0.2. So here we can see, okay, it's going pretty quick, so it's going to get unsymmetrical really quick. But this is neat to see as they pass by certain points. They will at some point become more re-symmetrical, if only momentarily, like how stopped clocks are right twice a day. Although, actually, I don't know if it's true that stopped clocks are only right twice a day. They're only right 2 seconds out of the day, but most clocks don't count more than a second, so isn't the stop clock right for the full second for each of those seconds? That's a significant portion of the day. That, that adds up. If you have 2 seconds every day, that's going to stack up. Now, let's try, we have a suggestion of one that looks symmetrical, and let's edit that in one, or let's try that briefly, but I won't destroy that one yet because there are some other variations to try. And here we have a suggestion that from the chat that I will try plugging in, hoping that I am typing it right. And by the way, throughout this stream, as I mentioned, I might mention some things I've been working on. So this one, we have a note that it is symmetric along the x-axis with rotation. Let's see. Yeah, if we do the color swap, I guess. So yeah, if we like, or if we rotate it in certain ways possibly. But yeah, this one's an interesting one. We have all these different spines. Some of these were the type of ones where when you zoom out too far, they don't get it, but the way they don't get it is cool. It's not quite doing it here, but some of them had these sort of patterned errors. Now, how can we morph this though? This one looks pretty asymmetrical, so I'm going to make it more symmetrical, looking for its equation. Here we had arctan y sine x, and what if we had arctan y sine yx instead of just the sine yx bit? And that sort of made it less interesting, but here we had a minus tan x. Also here, oh, I forgot, we should switch with, oh, that became xx by accident. That was supposed to be xy. Ah, there we go. Now, here we have, maybe I'll switch that for an x. That actually didn't change that much. That's interesting when we switch this one for a y or an x. Or what if it's both? Yeah, none of those change it that much. Oh yeah, even if it's not there, it wasn't changing it that much. This is interesting. Like, these look sort of like lightning bolts, but then you zoom in and you're like, oh, they're actually curvy. So another thing I wanted to note, one thing I have been busy on is another very in-depth, somewhat long, cool episode for the main combo class channel. Make sure that anyone who's even remotely interested in my videos on this channel checks out that channel, because that is where I put projects that I put a lot more time into. This is technically my bonus channel here. And the last few projects were very in-depth, so they've been somewhat spread apart episodes. Now let's add some A's in there just to see what happens at different zones of morphing it. Oh, that's a slow and steady morph. Oh, but this is cool. You can see, look up here. We're going to see this cross over to there instead. Whoop. Now I'm connected to that. Nope. Now I'm connected to that. Oh, we have one up there too. Yep. Switching which one I'm connected to. Now, so the last few episodes have been somewhat spread apart because they are very in-depth, and for a few other reasons I'll explain in a moment. But the one was about a really long quest I went on for finding four-leaf clovers, where I ended up finding literally dozens of four-leaf clovers. Then the next one, which was the latest episode on there, turned out to end up being... Okay, I need to simplify this so we can just look at a little bit right here. I'm taking off the minus tans and seeing if we can still make this interesting. Now, whoa, that turned out to be the latest episode on the Combo Class channel. Whoa, turned out to be half an hour and very in-depth, and it's about what I call hypertriangular numbers, and it also ends up mostly being related to Pascal's triangle and many cool facts about it, and a really cool open question about it, and including some really underrated numbers. So make sure you check out that one at some point. It's like the most amount of digital graphics I've ever created for something. This was before I've released anything that I've been working on with some other artists at the moment that I have been cooking up. But for now, this one, I made all of these graphics myself, and once I started making graphics, I got sort of perfectionist about like how much of it I was going to make myself. So I was like, I want to make the episode 100% myself. And that ended up meaning I didn't use any other graphics of Pascal's triangle or anything. Like, I made my own Pascal's triangles, and then I kept realizing, oh no, I need to show more numbers. I need to make a new, bigger Pascal's triangle, and so on. Then the next episode that I'm working on right now turned out somewhat similar. Now, that last one was sort of more just like to prove to myself in the world that I could make 100% of an episode myself. So I even filmed that myself. But then somewhat coincidentally at that time, it ended up happening for the next episode too, because I am sort of in the process of figuring out what I'm going to do for camera people. I have various friends who have helped me film combo class over time, and some of the main ones who have been like my main recurring camera people are pretty busy for a while. One of them moved, another one of them is going to be taking some classes. So I'm figuring out like working with getting another more recurring camera person as opposed to just more impromptu stuff with my friends. That's something I'm still working on, but that means that while that will be settled before too long, I have been filming more stuff myself, like on a tripod and stuff. And this next combo class episode, I did completely film myself as well, so this one was cool, but got some good juice out of that. I will come back to the comments in a moment, but I want to show some other variations of this. And for example, mixing up, having different combinations of these was one thing I didn't show yet, where we have some of them as secant and some of them as sine, or things like that. And recall that when A and B are 1, it's like they don't exist because they're multiplicative right there, so that's usually the first state I'll look at. And that when A and B are the same, but not 1, they will still maybe have a 4-way symmetry for some of these, not guaranteed. And that when they're different, we get some symmetries remain, but some get lost. So here, it's an interesting example to me of, we don't really know what ways the graph will be symmetrical when we design an equation to be almost symmetrical. And when we design an almost symmetrical equation, even if we make it not fully symmetrical, we sometimes still have some levels of symmetry due to all of the almost symmetrical bits we buried. Sometimes the almosts don't carry enough weight. So playing around with this one for a moment, basically I was noting that the next combo class episode, for those other like more practical reasons, rather than beginning as trying to prove it to myself, I also 100% made myself. Now, this next one that I'm just finishing up in the next couple days should be out pretty soon. I won't promise an exact date, so I'm not late on it, but it should be out pretty soon and it'll be worth it. It is a lot more homemade than the other one in terms of not using, they're both fully homemade, but it doesn't use digital stuff really. So there's like a 1 or 2 long like lists of sequences. I will probably show the digital version from the OEIS, the Online Encyclopedia of Integer Sequences, because some of those I might not write all of them out. But almost all of it is whiteboard stuff of various different types of numbers and calculations and equations and series of lists of numbers and stuff that I wrote on whiteboards. So that one has a pretty classic combo class vibe in how it looks. And it's going to be about a concept that some people may have encountered on another popular math channel, just the base 10 version mostly. But my episode, even if you have heard of one of what seems to be the main part of the episode, that you think you've seen it on another main channel, watch the episode, because the bits that the other main math channels that I've seen have covered about this are just the tip of the iceberg. Because when you look at these patterns and really analyze what happens in other bases, you can get a lot of explanations intuitively for why these patterns happen in base 10 that are the most popular part. So just make sure to stay tuned for that coming on the main combo class channel in a few days. Even if you think that, oh, this sounds like a concept that I've heard before, you've probably not heard all the details about the other bases or the ways I figured out that they help explain the base 10 version. Now, some of these episodes, and as far as not releasing as much bonus content on this channel recently, I've been dealing with some perfectionism recently. For some reason, I started feeling really perfectionist about whatever videos I would put out. So I'm trying to break free from that on this channel again, because this is my bonus channel that it's designed to a degree that I have one channel where I focus more purely on quality and one channel where I focus more purely on quantity. Obviously, my goal is to have quality in any content I release, but you have to balance how perfectionist you're going to be, because you know, you could make there's diminishing returns on perfectionism. Sometimes even negative returns. Sometimes if you try and work on something too long, it ends up worse than when you started. But even if that's not the case, there can be diminishing returns where, if I spend the first 20 hours on a video, might make a big difference over just spending 10 hours on the video. But then depending on the video, there's a point where each new hour you add is just adding a little bit overall. And it's like, I should have moved on to another video because I have more than enough notes to turn into the videos. I will be working with more people in the future on helping me with different ways of doing technical sides of the operation so I can go through more of my vast files of all the cool notes I have. Some of the perfectionism that I've been having with what I released recently also relates to a lot of the ideas that I want to put out are things I discovered and things that have not been fully investigated yet. And then I want to really get those right when I put out a video about them. So we'll see what comes. I'm not going to make as many promises about particular dates right now. Maybe in the future I will have enough help with various digital things that I can have more of a fixed schedule. But for now, I have to remind myself better to under-promise and over-deliver. So instead of saying particular dates, I will just say, know that I am cooking a lot of cool things and I can't wait for you folks to see them. Now, there have also been difficult things with my ability to film right here. There have been issues with my family. I shouldn't fully go into it, but I will just say one thing related is, although I am 31, so older than most folks who certain things happen to, my parents may be getting divorced, and my parents both owned together the house that this is behind. So things are complicated for my classroom. I'll make things work out. Combo class is my dream, and I will find a way to turn all of the ideas in my notes into cool videos, and I will almost definitely be able to continue having this be where the combo classroom is, but a lot of stuff's up in the air in my world. And I also am still getting through a lot of difficult times from the past. I had some surgeries 3 years ago, so still I have to, make sure I walk the right amount and the right way and stuff like that throughout the week. I had gained a bunch of weight. I have lost almost all the weight I gained. So to anyone who was wondering, you can't really tell because I have multiple layers on. I'll show you sometime. I actually have abs and stuff from the past because I used to be in good shape. But I've lost most of the weight that I had gained, and am feeling healthier in that way. And for those who follow the deeper parts of my quest, I had some issues with alcohol in the past, including part of last year. I had a bit of what I'll call a relapse because now I have not drank in over 9 months again. So know your vices, which ones you would have to avoid. Everyone has their own weaknesses. So it turns out my life works better when I promise myself that I just don't drink, even when I'm at parties and stuff. So know your weaknesses and what to avoid. But for anyone curious about that, who follows along with the deeper, more personal parts of my journey, I am proud to say I haven't drank in over 9 months. And as what I was basically just saying is, I hope all the folks who are like, oh man, some given week if I don't post much, know that it's not because of lack of ideas, and it's not because of lack of love for my combo class students. It is been a very complicated past few years of my life. I was in a wheelchair right before I started combo class. During grade -1, I had to get a major leg surgery, and I had to get another one. I had to get one when I had started filming combo class, and then another one even after it had started releasing. So things have been complicated, but I will get through them and continue to be able to show you folks my cool ideas. I'm very proud too, although some of the recent content has been slower. I'm very proud of the past few episodes I put on the main combo class channel, so do make sure at some point you check those out. The most recent one I have linked in the description here. And also, I will note again in the description, there is a Discord link for, I've been actually doing that now, like checking that to chat with people and stuff. So if people, want to chat with other combo lords and possibly chat with me as well, if the timing lines up, then feel free to check out the combo class Discord. There's various cool mathematical chattings, but also other topics, but mostly people's interesting experiments with math and more like that. If you also would be interested in helping provide any skills related to editing, audio mixing, or animation type things, also let me know, because that is what I've been working with a more private group for certain projects of mine that could use those things that, as I said, it makes more sense for me to be able to put out all my ideas to continue focusing on getting better at filming and learning how to use filming gear better, and not trying on the side develop a bunch of skills in things like animation. That even the fact that I edit all the combo class episodes is not my long-term dream. I want to direct them all, but I don't feel like editing is not my dream part of it. And so I'm working with some more people to hopefully be able to focus on what parts I'm best at. There's another part I'm best at that you folks are not very aware of usually, which is combo class has not experienced as much yet as it will of music-related things. I was a music teacher in the past, and before I made combo class, I had some music-related channels on YouTube. I have released, this sounds like a joke, but I have released dozens of rap mixtapes. I'm not joking. That you can't find them by searching like Demotro or my normal name or things like that. So I'll share them when the time's right. Some things I have shared on like the Patreon and will share for the like YouTube members at some point. I'll share it with everyone at some point when the time makes sense. But the soonest thing of that is going to be, oh, this is interesting. I like how we usually had these checkerboards where there were like squares that got warped. Here we have like a triangular grid that got warped. Well, I guess it's squares sort of cut in half, but still, triangles. The good old, these are, right triangles, but they look like warped versions of, that they're sort of approaching in some middle zone maybe, is some of them here look like the one that for some reason in school I was taught it as the name 45-45-90 triangle. Why the heck doesn't everyone just call it the isosceles right triangle? It's the only triangle that is both isosceles and right. There's a great combo descriptor name. It's when you're just given that name. It's two names already existent, and you're the only example of something that's both of them. And you come up with some other name for it based on an arbitrary system called degrees. So if you're a teacher, 45-45-90 should be at most the secondary term. The first term should be something like the isosceles right triangle, or I also like thinking of it as the square cut in half, the what you get if you chopped a square in half down the diagonal triangle. So, what was I mentioning? I was mentioning that the first taste of combo class music stuff will be a straight up music lesson on my main combo class channel. Well, actually, I've done a few live streams in the past where I made beats live on GarageBand, but the first main thing will be, there will be a combo class music lesson. And, well, several. The first one is just going to be about major and minor chords. These are very mathematical lessons. The way I teach it has a very mathematical method. And so it relates directly with the first few that I'm going to show, which are chords and scales, directly to modular arithmetic that I've made episodes about before. It will be described, like, how I have a bunch of clocks, partially one of the many reasons. I don't know if you can see all the clocks, but yeah, there's a lot of clocks around here. And One of the reasons is they're exemplifiers of modular arithmetic. Oh, leaf's fallen in the hair. They're exemplifiers of modular arithmetic. And that's one of several reasons. But sometimes I will make alternate fake clocks that have different amounts of numbers on them. Like maybe it only has 7 different spots that are labeled to show patterns about other mods. And with the music one, I'm going to make an alternate clock, but it has 12 things on it. Like I can take one of these, I probably will, that has like cleared. I need to find a clock that, you know, just has good separate notches for all 12 things, because I'm not going to need the numbers, but I'm going to need 12 notches on it. And for those who know music and are thinking, oh, that's the circle of fifths that I'm talking about, there's also just a more linear one. There's 2 different clocks I'm going to need to make. One's called the circle of fifths, and one's just a more linear view of the rotational pattern of a 12-note scale. I mean, it's not a 12 notes in the scale, but a scale that contains 12 semitones, but, or I should say an octave that contains 12 semitones. But with those, there are several clocks that will be designed to demonstrate this. I also might try and film some of it in the old music shop where I used to work, where they have a bunch of cool instruments set up, and I'm still friends with the boss and stuff. So, because I used to teach music lessons in a music shop before I made combo class. And not everyone realizes. But after that, I will warn everybody again. Once in a while I've warned about this. The time has not come yet. But in addition to music making and how it relates to math lessons, which my point about the modular arithmetic was that even if you don't intend on ever playing music, I think you'll find those videos interesting. But the other thing is that I will be releasing some music. Folks don't know, but if you listen to some folks know, if you listen to the main combo class videos, I design all the music in the soundtracks. They're all based on songs I've created myself that I then combine in a different way for the soundtrack. And they're more muted versions of the songs. They have like a treble reducer on them so that they don't bang like I want the song to do. You know, they're a little more muted, but for a soundtrack's purpose. Sometimes there are also versions where I fully remove or lower drums or bass or something. But the more banging versions of those do have lyrics that I shall record over them that are written, that there will be music videos on this channel as well. Not everyone will like, but if you see one, don't worry. It's not going to be the main focus of the channel, but I don't want 3 channels. This is my bonus all-purpose channel, and this is the logical place for me to put things like music videos. So they will come once in a while. It won't be clogging up the channel if I end up recording all of the songs that I've written, which I won't because there's so many. But even if I record the best quarter of the songs I have written, then rather than clogging up the channel with this, I would do like a music video here and there, and then for a lot of it, just like a whole album worth as one video, just maybe with like some interesting footage filmed over it or something. I don't know. We'll see, but there will be musical projects coming as well. And I think one of the next things I might put for the extra special supporters, who I should thank at least once in the stream, who help support Combo Class, one of the next things I might put for people like on the memberships and Patreon is just the audio without the talking of a Combo Class episode. Just for like informative or interest purposes, it wouldn't be that great to listen to because it'll have some gaps and it'll have some parts that are way louder or quieter. But I figure it might be interesting for some folks to hear. If people who can't afford to help in that way want to hear something like that, you can let me know too. But it wouldn't sound that good on its own, but I think it might be interesting for people to see. I put a lot of work into the soundtracks of the Combo Class episodes, and I haven't been doing soundtrack music in the bonus videos on this channel ever. Partially because they have a more live, improvised vibe where they have some of them are filmed just in one take. This video is fully live here. But I might start throwing in some soundtracks here and there in some of them when it makes sense, but I mostly do that on my other main channel, and I put them pretty quiet so they don't like disrupt the talking, because I'm still figuring out the best microphone situation. So I need to make the audio clear with the microphones I'm using, and I have to be careful with the audio not getting in the way of the soundtrack beats. So you can't fully tell, but I put a lot of work into the soundtracks of those, many hours per episode, of which beat I've made in the past goes where, if it has extra parts of its sound changed, how one will fade into another, things like that. And I don't put like sound effects and stuff like that, at least currently. So if you do hear birds and stuff, then that is real, actual luck. And if you do hear a bunch of wind, I try to avoid that and try and film and keep takes that don't have too many wind noises, but it comes up once in a while as well. So those are just parts of the outdoor classroom. And there's also a lot of, well, let me look at our comment. I'm getting carried away on some rants. What I should do for a moment is change up our graphs a little bit and check a couple comments. And right here, for example, I want to try something involving exponents, but sometimes they make stuff vanish, because sometimes the exponent flips everything out of one of the quadrants, or just doesn't exist in that quadrant. But let's see what'll happen if we try and do that. We're going to take y to the power of x. So yeah, we lost the bottom half. If we did the same thing here, what are we going to lose? Are we going to lose all of it, or are we going to lose half of what's left? We're down to one quadrant. So that's the problem with the exponents. The exponents make us lose a little too much. So here's an interesting, when we're thinking about it in terms of symmetry, let's note that although this looks really symmetrical, I mean, let's even just do this. What's x to the y greater than y to the x? This was an example I wanted to show in the stream, just as far as symmetrical things. So this is a symmetrical looking equation. They're just, each other. We need them different. I can't have both sides be the same if it's an inequality, because if it was just greater than, nothing would be filled in. If I have this greater than or equal, everything would be filled in if it's it compared to itself. But here, swapping them, you think, okay, maybe we get some symmetry. Not really. The symmetry, well, we do get symmetry in this. We get one type of symmetry. We get across the axis of y equals x. If we flip across that and then switch the colors, we get it, sort of. But we can't switch the color of any of this. We have to only flip this eighth of the plane and switch its colors. So a little bit of very limited symmetry going on there. And the other ways we could look at it that would be nothing, like that don't even work, is if I do xy is greater than or equal to yx. Here they have nothing filled in, but technically it should be like everything filled in, because it's saying something is greater than or equal to itself. And so we can't have fully commutative things if we're messing with that being fully symmetrical. We could try things that are slightly asymmetrical along those lines. Like if I tried x times, well, this would require exponents to a degree. Exponents break the symmetry in a way. We can also, when we use the signs, having something in and something out of a parenthesis and then swapping those can be an effective way to have it everywhere on the graph, but still have a symmetrical-like thing that makes something interesting. Sort of like what I tried there. So here I want to try that, but instead of trig functions, what if we had, for example, like x times rounded y is greater than or equal the opposite. Now remember, round is going to round it to the nearest integer, and as I've covered in a previous live stream, rounding makes things less round. The English language has so many problems, and one of the many problems is that in math, round means like two opposite things. Like one of them's like, okay, this is pretty round, right? The other is like, I round something that would look like curved if you visualize it, that I like make it all blocky by rounding it to the nearest integer. Like if I have y equals x squared, And then if I have y equals round x squared, it's like, this is way blockier and less round than without that, especially with a circle. So if you use the circle equation and you round it in the right spots, like, this is, I just need to re-show this really quick because I think this is so comical in terms of how the language has round mean these opposite things. So less than or equal to, and like a bigger circle. So this is when we round the circle equation. We're far enough away that you can't fully tell. But if I didn't have round either of these places, it would be a perfect circle that would look like this. So what does putting round there change? Oh, it makes it less round. Okay, so, oh, you can't even see that equation. That one is this. Okay, which should be, if I don't have the rounds, round. Well, if I don't have either, it's round. Okay. So we got to pick if we want to round or be round. Now, here, if I try something like x, oh, I deleted the one I was working on. X round y is greater than or equal to y round x. Ooh, so that's pretty interesting. This could be a seed to look off from. Oh, and that is a sort of unfortunate, like, center. Looks a little swastika-like. But the rest of the graph is pretty cool here, and we got a bunch of triangles flying from different angles. And this is the sort of one like before where we have at the right angle, like when you're right here at, like, if we were at y equals negative x, the triangle right there might be exactly or very close to an isosceles right triangle, wherever that line is. It's hard to tell right here. But as we get further, they get more jagged, but these are not quite separate triangles. These ones, you know, combine into little jagged strips. So that's round, and there's some other interesting ones in here, if you go in their function menu, that we've played around with in the past, because we have our trig functions, and when we go down to round, that's in this number theory realm. And so some of these require 2 inputs, like number of combinations, requires something comma something else. But we could also just try, like, how different would floor be compared to round? Oh, well, if one's floor and one's round, this is quite different. So here we get, that's interesting. Yeah, when one's floor and one's round, it looks much different. What if one's floor and one's ceiling? Whoa. See, very different. And here we're getting different sorts of actual symmetry that emerge. It appears, at least, or are we? If these are symmetrical to that, they're like offset. That's interesting. Because it looks symmetrical to this, but this one has like an extra block right there. This one has this extra row that this one does not have a column similar to. It's like the first column there is like the second row there. So that's interesting. I guess it makes sense. It's offset by 1. We have a floor and a ceiling. You know, that would be 1 apart. But playing off this, what if we had squared them? Ah, that's interesting. So we have the floor there and the ceiling there, and from afar, it looks sort of just like a parabola-ish thing. Not actually a parabola, but somewhat like it. But then you zoom in, and you're like, we have this long. So here, that's interesting. We have just one long string of them. But then when we get all the way up here, we get a few, oh, these little dots. Were they already there, or do they fully vanish? You know, are they, at the rate they're shrinking, if it's an additive rate of shrinking, they'll be gone. If it's a multiplicative rate of shrinking, they'll always be there, just smaller and smaller. It seems like maybe they're always there, just smaller and smaller, but it's hard to keep track of them. But either they were really tiny or not even there, and here we can see them emerge, and then it flies all the way over. They get big enough, they like break it. So that's sort of what it looks like. Like here we have this pattern going, but then like these little ones are like, da, 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 and they start offsetting the pattern, and then they break it. That's just one way of visualizing what's going on, but it's sort of interesting that instead of many fractal-like rows, we seem to have 2. We seem to have like one normal row and one weird. not row, but, you know, one normal, I want to say line, but it's technically not a line either, I don't think. But, you know, one linear, not linear, one thing, and then another thing in a string. So now morphing these a little bit more, if we had made one cubed, here we have another sort of break on the symmetry, but now if we're going to break that symmetry, let's make this more symmetrical. So now, well, let's make them round. Round's a little more fun than floor or ceiling. Round's a good compromise, because whenever I pick floor or ceiling, I always feel bad that I didn't pick the other one. It's like, feels so arbitrary to pick floor versus ceiling. So, you know, here there are big differences, but round, great compromise. Round will, you know, have the best of all worlds sometimes. So here again, we have sort of like two. Whoa, this is interesting. We always have like two rows or two strings of things. Or here we have three, sort of. Well, it's hard to see exactly what we're defining as being a line of things growing. There's a few lines. This one has like a sidekick. This one has a really small sidekick, I guess. Does that one even have a sidekick? So, there's some interesting things there, but they're all pretty small scale. That's to really quickly just try breaking this symmetry a few different ways. If they're offset, we have pretty similar things. Interesting where the round cuts off a chunk right there. Look, it cuts off a chunk at a strange spot. Now here, I'm assuming that the strange spot is related to a cube root or fourth root. If we had a strange spot here, I would assume it's related to pi, because pi shows up a lot as like where these things do things. Sometimes you can straight up see a weird blob that you're like, oh my god, the corner of that is exactly at pi. I can just tell. And here, it's probably more likely to a third root or fourth root or something where it cuts off at a strange point. So let's try a little combo just to try flipping it. So we had x round sine y. To shorten it, we can just put it like that. And then we're going to have y round sine x. Okay, here's where we start getting into interesting territories. I mean, not that the previous ones were not interesting, but this one is getting close to like the maze type things that we've seen before. This looks sort of like a tunnel system where, you know, a bunch of sewers systems that hopefully they connect. Okay, if this is the actual like sewer system, don't go that way. Where is it gonna connect? To connect, I guess you have to be close to the origin. So, and in fact, they don't fully connect. They get or these ones connect over there. We could, oh yeah, if we had to sneak through, we could go, So this is sort of like a maze. So like if I was like, okay, well, sort of, because if I started here, I might be screwed though. Does that one ever get, are these getting closer or staying the same? Yeah, I don't know if that one ever connects. But this is looking interesting. What if we remove one of the rounds? Is it going to unround one of the axes or dimensions? Oh, it unrounded some of it. Oh, it made our passages change. So now we can't get through that way, but we can get through that way. So somebody see if you can design a really cool maze out of an equation like this. I think that would be so cool to have mazes that were like solvable, but that have a graph equation for them like this. And then you can say where you don't need to write start and finish on the graph. You can just name coordinates. You have to get from, you know, -10, 5 to this other coordinate. So let's try with the tangents instead real quick, and then with the secants, because those are always a fun substitution. Okay, this one's sort of cool the way it, like, if we follow this line, even though it gets cut off and, like, skips places, it's trying to sort of go and, like, loop around in a sort of way. Let's see real quick, when we removed it, it looked sort of like this. And this is a simpler version of one of the ones we tried before, but already quite cool. And here, what are some of the other ones that were extra notable? were when we looked at things like that required two inputs. And so here, instead of having an x out and a y there, let's go back to some of the other ones that we've played around with previous streams, but make them extra symmetrical variations. Like one that we've seen before is when we have the number of permutations. This is when the number of permutations of x of y. So I'm not going to fully explain this. I explained what this means to a degree in a previous stream. It's called Combinatorics, which Combo class is not named after, but is a good fit. And it is a formula that actually involves factorials that to graph it, they're going to need to extend that via what's called the gamma function. So understanding what's really going on here takes a few steps, but whether or not you understand it, it can be neat to play around with briefly, because we're going to try a few ways that we could make these symmetrical-ish. Let's say that we had all of these squared, and so far the symmetrical-ishness was that we swapped where x and y was in that two input thing, because order matters among this. It's not with this formula itself, but of combinatorics formulas in general. They often will be asking questions like, here's an amount of items, and then if the items if order did or didn't matter, and if you do or don't have duplicates of the items, and then having some amount of the items, then, how many different possibilities were there? And so different combinatorics formulas vary how many items there were total, how many items you were talking about among them that you needed to do something with, and then vary based on whether order matters, vary based on other traits. But this can be also described in terms of the extension to factorials using the gamma function over here. But real quick, just to see what happens when we almost symmetricalize it, 1, 2 to a 3 right there does a lot. 2 to a 4 won't do quite as much. It does change it, but in a more symmetrical way, I believe, because 4s and 2s are very similar powers. If I did 2 to the power of 2 to this one, that's the same as 4 right there. So this is when they're both 4 right now. But what if we had switched? What if the x's were 4? We get this. And if the first ones were the ones that were 4, we get this. So these ones, pretty interesting, but relatively simple. And let me take a look at our comments real quick as what we're going to try right here. First, let's just switch, since this involves the factorial. Let's do a quick factorial experiment. Here's where we have x factorial being greater than or equal to y factorial. What if we find a way to make them slightly different, but almost symmetrical? What if we say 2x plus y factorial is greater than or equal to x plus 2y factorial? Now here we have some of that color swap symmetry going on, where here the filled-in zone looks like the non-filled-in zone there. So we still have a good amount of symmetry down the y equals x line if we allow color swapping, but it gets a bit skewed here. Comes off at a different angle. Now here, we're turning the 2 to a variable. So when I set this to 1, wait, why isn't 1 working? Shouldn't 1 work? Oh, no, that when it's 1, they're the same as each other on each side, because I no longer have one of them outside. So they need to be different. But depending how close they are, we will get these lines that radiate off having different sizes and different slopes. And at this point, it's pretty busy. We can see a lot more filled within 3 of the quadrants. So that was when we did that with factorials, but I think that's a good way to try some almost symmetry with some other things as well, having ax plus y and x plus ay. For example, here is when we have, just for sine, we sort of get a purely mutating chessboard. When I have 0, we get this checkerboard-like thing. This is an example of where we touch down at pi. Remember how I said some things have the coordinate pi? Well, we got one right here. Do we? No, that's pi over 2, I bet. Is it? I bet you that's pi over 2. So, and because here, okay, here's another one. I bet you even more that is 0 pi. I mean pi 0, that coordinate, and that's 0 pi. So, and I bet you even more than either of those that coordinate where it touches there is 0, 0. I'll bet you even more than that it doesn't touch at 2, 0. Okay, anyway, here, this is when they're the same. But if I mutate it, I get all sorts of different checkerboards. So you ever wanted a checkerboard simulator of where you ever wanted to feel like you were trying to stare at a checkerboard and really something weird was going on? Or like you want to design a game and for some reason you want it to have a perfect grid pattern but not shape? Like maybe your game piece, maybe you need 3 game pieces per square and they need to be in a line or something. You can make your own grids of different sorts. And if we did something similar with one of these, we get other things. There's a bit of a crazier grid-like thing. When I'm at 0, we have this, which, has a grid-like structure. Actually has 2. This is really cool, actually. Looking at what's going on here. This is one of the ones that sometimes I get spoiled by the really magnificent, dense landscapes that have like fractal-like complexity that I gotta remember, don't miss the tiny, beautiful details. This one has 2 separate square grids going on that are overlaid within each other. Look, there's a square grid going diagonal, and there's another square grid that we can see with these cut out of there, filled in there. There's like another square grid that alternates its colors in a weird way because it's doing its colors being visible by being sort of the opposite of whatever's going on somewhere. And so 2 grids that touch at each other, meaning this one is going to have something to do with the powers of 2, with the square root of 2. Because when I tuck a square in a square like this, we're going to have some traits related to the square root of 2 on some of these coordinates. In fact, I wonder... So, okay, let's see. Could these have been related? That might just be related to pi. But somewhere we'll have something related to square root of 2s when we're tucking squares inside squares. Now, here, let us... And as an example of what I mean by that, the side length of this... Imagine it being here. The side length we can see of the big diagonal square grid we can see is the diagonal of that one. And the diagonal so that means that this square grid has squares that are square root of 2 times larger of side length, which means they have exactly twice the area as the smaller square grid. We can see the twice the area thing visually, too. You can imagine how you could pack, like inside this square, the diagonal one, you could pack these 4 to fit that. If you flip them all, they would fit perfectly. So we can see that the area of that one is twice this one. We can also mathematically justify the side length must be square root of 2 times larger for that grid and that grid. That's what you get when you perfectly overlay 2 square grids, and it can be hard to visualize that. So here's sort of how you'd want to visualize it. If you have one grid, you colored it like a checkerboard. So where's just the normal grid? Which one was that? Was that sine x greater than or equal to sine y? Is that the same grid? Yeah. Or no? This is a different grid. Will cosine maybe slide it over just enough to make it work? Oh, it did! Oh my god! I didn't think that was going to work. Sine and cosine, I'm used to it looking just like a slightly offset version of sine and not changing it dramatically like I mentioned earlier. So here, sine was a bit off for like, oh, this is a grid I remembered. I was wondering if it overlays or it doesn't line up exactly. I was like, maybe cosine just happens to line up. Bingo! So basically, imagine you wanted to make a grid. So here we made a grid. And to make it visible that we've colored it in a checkerboard-like way, we would color in half the squares. Now, what if we wanted to overlay another grid? Well, the logical way to do that would be for the filled in squares, to show the square in them, we cut that part out. We turn it white. And for the non-filled in squares, we turn it purple here. We fill it in. And that's exactly what this does. So that's pretty neat. It's like the way that you would try and overlay two grids if you wanted the first one to look like a checkerboard and the second one to be visible. So now, if we morph it, we get them contorting in some different ways like that. So here, if you needed a slightly skewed version of that, you could always do this. If you needed rectangles with rhombi inside them, you got your rectangle and your rhombus. So that one was pretty neat. What if we, as another way of making things slightly asymmetrical, throw a minus in the place where one of the pluses was? Oh, this is kind of cool. I think it's shrinking too and rotating. So it's just, whoa, but then I go negative and it goes back. So this is pretty cool. It's like, hello. Okay, I'm going back down. So, and then I don't think it ever does a full rotation. I think it like slows the amount it's rotating as we go up and maybe approaches a full rotation at its limit. Or it's hard to tell. I would have to look closely to see if it's like 1 or 2 full rotations or what that is the limit. But interesting there. Now, this was, well, first let's check when both are minuses, just to make sure that's not crazier. Nah, better when one was plus and one was minus. Now, what if one was a times? Okay, that changes it a lot. Not even close to symmetrical now. And in fact, multiplication is so much different than addition and subtraction that remember that subtraction, way more like addition than multiplication. There are ways, of course, that addition and multiplication are more similar, like on positive numbers, that they make them grow, positive numbers larger than 1. Both of them will make stuff grow. But there's a lot of ways that multiplication and division are the next level above addition and subtraction, and that a lot changes on that level. And the big difference ties down to the fact of the identity element being different. The identity element being 0 for additive or subtractive things, or being 1 for multiplicative, or, multiplicative covers division and additive covers subtractive, basically, because you can multiply by a fraction to divide, or you can add a negative number to subtract. So remember that, subtraction is way more like adding a negative number than, it would take a lot more to describe a subtraction using multiplication. And a lot of the beautiful things at the heart of number theory that are strange lie at this strange dichotomy that occurs when you look at a pattern that involves both addition and multiplication. For example, if you look at how far apart are prime numbers, how far apart additively is this concept that's defined based on multiplicative factors. And, a lot of the popular ones, like the Collatz conjecture and stuff, part of why that's so weird is that you have addition and multiplication, and they follow sort of different rules, so they get in this strange balance. Now, let's see what happens when one of these is b. And let's first make it closer to the 0. So they're going to start both at 0. And this was when one was plus and one was minus for secant, but I think it may have worked better for, it was either sine or tangent. What was the one that worked well for this? What was the one that had that grid a second ago? Oh, something went weird here. Something went really weird here. X minus by. Something... Well, okay, so that's if we have them... Something went weird there for a second, but here is one other option. This is when we have the only difference on here. Well, we have A and B different, but while A and B are at the same spot, the only difference is that here we have a minus and here we have a plus, but we do even have the same order. Like y is the one that gets the coefficient in both cases. So these are sort of rotating triangles or cut in half square-like things. So that has some cool shapes, but not exactly the most complicated. But now let's switch these back, where we have these reverse as well. And pretty simple on tangent. Well, I wanted to go to that one that was extra. Whoa, this one might be neat, the mix. We got a sideways ocean. Here, wait, let's see if we can orient the ocean the right way. No, that's not it. Maybe that'll be better when we do this, but no, we need the ocean going the right way. There we kind of go. It's an upside down ocean. Negative. No, that didn't work. I'm trying to flip it. No. Okay, we have an upside down ocean. Anyway, and kind of sideways-ish ocean. Or no, wait, is it sideways-ish? Sort of optical illusion-y. It looks like it's slanted downward, but it doesn't end up slanting. It ends up following the lines. So, but don't you think, like, isn't this sort of optical illusion-ish of it? It looks to me, at least, like each of these rows, if you look at them, like, not that closely, like they're slanting downward. But then on the other hand, if I look at these ones, I could see them sort of slanting upward. A lot of optical illusions you can see one way or another. Oh, but some optical illusions are crazy. But for now, let's get back into here. We had tan and sine separate. Where was the one that had our grid in grid? Well, this is a good starting point. We got a morphing grid. There's a lot we can do with this. First, here's what I'm curious about. What happens when we round like a already really square thing? So here we had a grid. When we round that, is it even going to change it? Well, because yeah, it's a square looking thing, but it's not square at the integers. So yeah, when we round that, it completely changes it. We get all these pluses. And I like this because they're islands. And when we have islands like that, we can do cool experiments on them. This might smush all the islands too close together, but they're still separate islands. So, what's a way where we can not smush them too close together? Maybe we need to just like add something in here. Maybe they each get plus the sign of the other one. So, the islands have connected, but they're still interesting. It looks sort of like one of those things where the negative space is the same as it. It's not actually that, but it like resembles something like that. When you look close, you're like, this is the cutout and that's some flip of it. But they're different. So, do they always stay connected? Anyway, I keep saying that I'm going to check the chat. Thank you to everyone who has left some random thoughts. Oh, yeah, and someone said to negate the inequality because the anti-waves, that makes sense. Because the anti-waves were the waves, we could have just flipped the inequality. And I don't have time to answer all of these comments, but to anyone who mentioned random cool things about math, yes, cool concepts, or to other stuff, I will look deeper into that at some point. And thank you to everybody who has left thoughts about some personal things I've left. I'm not going to get too deep into any more personal stuff in this stream, except I do have to note there is terrible stuff going on in the world right now, too. So I don't know what to do about it. It's, turning my channel into a political channel won't help me have a good impact in the world necessarily. I'm already trying to have a good impact just through educating people about enjoying learning. And that's sort of separate than like wanting to share all of what some people would consider political thoughts I have about the world. But I will say there's some really messed up stuff going on right now, and I don't know what I can do about it, but I support people who are protesting things and people who are doing anything they can to change some of the systems going on in the United States, in Israel, in Russia, and in some places where terrible things are occurring. So I don't really know what to say about that, but maybe I will make one political video at some point. I've considered doing that before, but people don't always like when channels that aren't about that do that, but it's hard to bite my tongue sometimes because there's such absurdist things that have gone on. And if you only trust me for my math, at least trust this. All of the math justifying all of the things going on in the United States right now is complete lies and nonsense and fake. Any formula you see that is supposedly explains what the government's doing right now, those formulas are absolute nonsense, fake, wrong. So that's, if you only trust my mathematical side of it, it is any formulas that supposedly are justifying terrible things going on right now, please think twice about them. Please check if they make any sense, and you might note, oh, wait a minute, that formula makes absolutely 0 sense when you think about it for 2 seconds. So that'll be all about that. To anyone who is in the middle of one of those crises, I don't know what to say other than good luck and a lot of bad stuff going on in the world. I try to, remain positive because I could volunteer to have an impact in some of these things. Perhaps I will. I've been to protests for things in the past, and there's ways to volunteer for organizations to help things. But it's not like necessarily the best way to invest my time to have a good impact in the world. It's somewhat a separate thing for what I've been building for being able to have a good impact on the world, which is getting people hooked on learning cool things about numbers and plants and stuff like that. So for now, I probably will continue to bite my tongue about most of my political-ish thoughts and just say that in combo class, anyone is absolutely welcome here. Combo class is not anti any gender, any race, doesn't matter. I'm not, any immigrant of whatever gender, I don't care. Combo class is open to all humans because we are humans together. So with that said, I hope those things, that the world slowly improves over time. There are some beautiful things in the world, and sometimes all you can do is, maybe pick once in a while to volunteer for something or help out in some way like that. And in between that, still got to try and appreciate the world. So one thing that you can appreciate is local plants. And one plant that I have here is my 4-leaf clover plant. So as a little plant break right here, to anybody curious, I'm in my episode about 4-leaf clovers. I showed that clovers fold up at night, and I didn't show what 4-leaf clovers do because I didn't really get the chance to see a 4-leaf clover at night. I picked the one I had gotten in my garden, and then the ones at the marina, it wasn't night when I got them. So the clovers I found, they were all either picked or just filmed and left there. Speaking of which, I was at the marina today and I found 2 new 4-leaf clovers, and I just left them this time because there's more 4-leaf clovers, but I have enough for now. If I find another 5-leaf one, I'll take it, or a really beautiful looking 4-leaf one. But I found so many during my clover quest that today, when I found 2 new ones, I was like, I'm just going to leave these. These ones were closer to the trail than some of the other ones I'd found, so there was like a chance someone else might come across them. Now, as far as what the 4-leaf clover does when it goes to bed, I hope you folks have seen my Clover Quest, the part of the episode at least, that shows what clovers do at night, how they fold up in a strange way, a different way than the clover-like plant called oxalis. That folds up in like a trilateral symmetry. Clovers don't. It's crazy. They have a dominant leaf, and the other 2 leaves fold up under it. Clovers are not trilaterally symmetrical. They look like it. It can help you find a 4-leaf clover to gauge an approximate difference from trilateral symmetry. However, they're not exactly. They close up. Now, as for what the 4-leaf clover does, I think that's going to depend on the 4-leaf clover because there's a dominant leaf and 2 non-dominant leaves. And the fourth leaf can sprout out from a few different places. So the 4th leaf, I believe, could have sprouted from a non-dominant leaf and perhaps been tucked under with the other 2. With this 4-leaf clover, it looks like the 4th leaf came from the dominant stem, The stem, well, it's one stem here, but like you can see that on the dominant leaf, the stem has a thicker extension than the extension of the stem to the non-dominant leaves. So here, this is going to be hard to see, but this is the four-leaf clover. I'll get a better video of it sometime, but this is the four-leaf clover, and there are two under there. So it did fold up such that two leaves went, oh, there you can kind of see. Two leaves went under, and two leaves are on top. As opposed to, usually there's two leaves under and one leaf on top. You see, like that, sort of. So, and oxalis does a different thing. So, I have to be careful leaving this back here, though, because all these leaves fall. I don't want, like, too much random, I don't want a giant tree branch to hit it. Sometimes giant tree branches fall down here. The combo class has several random hazards that can occur. And this is, I just need to show you this branch. The good thing I was not back here when this fell. Okay. I can't find it. It's dark, but later it's actually happened in videos before that branches have fell. So I'll trust that you folks know, but I can't see it right there, but there's a giant, it was really big that when I came back here, I was just like, oh, good thing I wasn't back here when that fell. So the good thing is this is actually just a very rarely fruiting or not very much fruiting plum tree that's up here. So I'm going to try, it's about the season where I could try and get plums from it. So back to Shrunk to play around with this. That was the little four-leaf clover interlude. I'm trying to grow some new ones. There is new sprouts, so I don't know if you... I guess I want to show that part of it real quick, too. It has not flowered yet, but I do have... Whoa, big bug. I do have faith... Whoa, you see that big bug? Okay, I'm pretty sure that that's a small crane fly and not a really big mosquito. I'm hoping that's either a small crane fly or a really big mosquito. Okay, but here, it hasn't flowered yet. But this sprout, where is it? Where's the, oh yeah, this sprout over here is entirely new. So this is separate. This is with the main one. That little sprout right there is a new bit. It's hard to see there. I'll show more footage of it once in a while. I showed a little closer of the plant in a short I put out on the channel recently, and I am going to be putting out more shorts on this channel. Some of them will overlap with facts that were kind of buried in a combo class episode. So some of them I might not send to the subscription or notifications because I figure that people who are already on the shorts tab they'll see it if they watch through my shorts. The algorithm will give it to them, hopefully. But although they're changing a lot of stuff about the algorithms these days, and not everyone will want that in their subscriptions. So I don't remember the exact details of what settings I am or am not able to do in that regard, but I might have some of the shorts that I make. There's a lot of cool facts I never shared on the shorts page that were or in any video on this channel that are buried somewhere in a really long episode on my other main channel. So if you're a diehard fan, you may catch a few overlap facts, but it'll only be the ones that are like, I have a new, better way of presenting them, or a new example to add, or something like that. Now, as far as other bonus videos on this channel, I actually have several filmed. I just need to edit. I've just been not focused on editing for this channel right now because I fell waist deep into another main combo class episode. But here I'm just going to mess with some floors versus ceilings. And this is a cool, like, patterned thing. Now, so I do have some videos filmed for this channel that I need to edit together, which I will do as soon as I finish in the next few days this big episode I'm working on for the main combo class channel, which, oh boy, did it have a lot of whiteboards I ended up writing. Because sometimes I go really down the rabbit hole of like perfectionist about some arbitrary, oh, this is a little different than what we had there. perfectionist about some arbitrary seeming thing. And in this one, it was that after I made a few like really homemade looking whiteboards, as opposed to like there was hardly any digital text in it, I was like, now I want to do all the episode like this. So there's going to be like barely any digital text in it, only when we have to look at like a really long list that I don't want to write out. But almost all of it I started writing on whiteboards, and then I just like carried along with that vibe. And it took a while with the amount of facts because, as I mentioned earlier, it's the type of episode that is an episode worth just about a base 10 pattern, but that has been covered by some popular math channels before. However, the videos I've seen about it have not gone deeply in depth into all the cool patterns you can see on the big scale of many different bases. And in fact, some of it has been discovered since those videos came out. So some of it's new, and a lot of it just wasn't in any video I've ever seen. So this is going to be the comprehensive guide to a very interesting topic about number digits in various bases. And I'm going to try and get that out in the next few days, but it will be out when it's ready. And one other big thing I've been working on. So I've mentioned before that might have sounded like a joke that I said, I'm going to write a whole book about why Threeven and Throd numbers are important and underrated. Well, guess what? It's true. I've spent a lot of time beginning to compile my notes that I've taken over the past about 3 years. So in grade -3, it's about time to compile all of those notes right now. And I have many half-finished books that I really want to finish and publish for folks. And I will try and make a lot of them even free or as cheap as possible because it's about sharing the ideas. This is really interesting there. It's about sharing the ideas, not about making money, apart from the fact that I do need to survive. So some things I will need to sell to survive, but to eat food and such. But I want people to hear my ideas, especially the ones in my half-finished books. So I can't wait to try and get people to be able to get those ideas and see them and hear them. And it kind of makes sense for the first one to be the Threeven book. So I'm going ahead with it. I am going to write it's going to be long. I have a lot of notes about Threeven numbers. It has several very important points. People might think that, how much can you say about Threeven numbers? Like you're going to make some point either in the first few chapters or save it for the end about how Threeven numbers are important for some big reason. And in between, just like what? A lot of facts about 3? No, it is the most important journey. There are several. Some of these I will turn into episode topics later as well. But there are several reasons that I've learned on this quest of why the number 6 and multiples of 6, which are Threeven even, are so fundamental and important. And I would need to bite my tongue to spoil some of the things I've realized about the history of humanity ending up at base 10. So part of the book is why we should count in base 6 or possibly base 12 if people don't go for base 6. But a lot of the book has whole other arcs. There are several arcs about why Threeven numbers are important and underrated. It's also going to be a very strange thing for a math book. There's going to be some sort of twists of sorts that are uncommon stylistically for what you might find in a typical number book. So it will be somewhat textbook-like, but it will be the strangest type of textbook of a certain type. It won't be a common type of textbook. So please, if you ever see a book from me even if you abandon all my channels, if you ever see a book from me out in the wild someday, please know that those are actually maybe the coolest ideas I've ever come out with. Hopefully we'll get video forms as well, but many of them are saved within book manuscripts. And those are the things I will unveil as we continue Combo Class. Combo Class is primarily a video project. However, it will tap into my 3 main artistic passions, which are making videos, which I call filmmaking, but some people are like filmmaking, but like some people don't call YouTube video making filmmaking because it's not. Some people use film just to mean movie, but I use the term filmmaking, I think applies to making a good YouTube video as well. So my main artistic passions are filmmaking, music, and writing. And Combo Class has a lot of writing involved. I brainstorm large amounts of notes of approximately what I want to say in episodes. And then I do them somewhat improvisationally. They're not scripted, but I have large amounts of written brainstorms for approximately what ideas I want to convey in a given episode. And so the writing is certainly involved. You can hear the music involved in soundtracks if you listen on the other channel, but those will be more involved over time. Various other ways that, although these are videos, I'll find ways to incorporate my other two artistic loves. Now, and I like a lot of things artistically, but those are in a way just the things I'm most skilled at. In another way, the ones that I find most interesting. But like, I like things like painting, but I'm not good at it. I haven't dedicated time to painting. I have dedicated time to those other three. And always remember that apart from that type of artistic passion, one of the most important things is to love nature and to love the plants and animals around you. You don't have to love all of them. I don't like mosquitoes, but, to find plants and animals around you that you do love. And humans count. They're an animal. So I don't need to say and humans. They're just counted in the animal category. Okay, plants, animals, and fungi. I shouldn't leave and protists and eukaryotes or whatever. I shouldn't leave out all the other kingdoms. I'm being offensive just applying this to 2 kingdoms. But it's actually really weird. Something I want to make more botany type of episodes, but part of why Combo Class is so heavily math is that's like what I can make a good video about with no supplies. If I want to make a good botany video, I need to be around a lot of examples of that plant. If I want to make a good, science experiment video, I need chemicals or whatever. So math is such a brain-like thing that even with no supplies but a whiteboard, I feel like I can make a good video. But I do have a lot of other subjects I would love to cover when I have the right props or the right location or whatever. And one of the botany-related things I would like to cover, or maybe anti-botany in a way, is under some metrics, plants and animals are not the two of like the kingdoms that are most similar that involve animals. There are some ways that animals are more similar to fungi that include mushrooms, and plants are more different. So that's a trip to think about. It's not, there are many metrics, there are other metrics who are more similar to plants, but under some metrics, we're more like mushrooms. So don't be surprised if some secret to life relates to finding like some mushroom on another planet or something. If we find life on another planet, we think it's going to be plant-like, but why are we discounting the other kingdoms? Oh, I can't wait till they find proof of alien plant life. I feel like it's not guaranteed, because I feel like it's almost guaranteed that somewhere in the universe there is some form of life. Not 100%, but it's with the size of the universe, it feels almost guaranteed. But what's not guaranteed is that the dots of life in the universe are close enough to reach each other. That we don't know, are all the aliens really far apart from each other? Like really, really far apart? Like, how like light years of light years far apart? Because that's, still something that could possibly hold us back. However, I'm optimistic that we're going to find some type of bacteria or plant-like thing on another planet in my lifetime. I don't expect finding an alien that we can talk to within my lifetime, but I'm still open to that possibility. I do expect, this is part of my own comboism religion that I'll explain someday, but I do think the aliens will watch Combo Class someday. I don't know if I'll get to talk to them, but my videos are sort of actually for the aliens. Not necessarily the present tense aliens. They might even be like even if right now, even if an alien was watching this live, like currently, due to how long time takes with the weird relativity of the universe, they have to be in the future to be watching what's now, because it takes a long time for the light and sound that describes this to get somewhere else. So, you know, maybe in the future there are aliens watching what is happening right now. So maybe I should cut a big hole in the trees up there just in case they get a telescope at the right angle. I'm partially joking, so don't think I'm going crazy or anything. But I do actually like following along with conspiracy theorists and like reading through like a few subreddits that are dedicated to the slightly more crazy side of ufology, or however you would pronounce UFOlogy. Is it just ufology? But in any case, some people really overanalyze really poor quality footage. Like, you know, it seems like it would be pretty easy to film something that looks close enough to a flying saucer that it would trick a lot of people. Like, I'm not recommending anyone do this, but it's like some of the videos that you see get like traction in these communities of being proof of things. Is like, I literally could have just taken out my camera and gone like, thrown up like a bean in the air or something, or like, you know, and taken a really blurry photo and tried that like 5 times until one of the times I got the bean blurry in the photo. And like, that would, you know, depending how well I threw that bean in the air, some people would think it's, you know, concrete proof. So you've got to be careful with the pseudoscientific side of aliens as well. I do not think necessarily that aliens have visited Earth. You know, that's certainly still an unknown. So if anyone thinks that that is proven, be skeptical of that data. Now, but also if anyone tells you it absolutely hasn't happened, then, you know, that's also worth a discussion about, you know, we don't really know that. We make a lot of guesses about what has happened in previous levels of the Earth and the universe. There is so much unknown about history, just like, I mean, currently, there's a lot unknown about yesterday, but even like a little bigger than that, there's a lot of unknown history just from a few hundred years ago. So if you imagine how much unknown history there is from the rest of the planet, not saying that's evidence that aliens have visited, I just mean that among scientists, you sometimes find people who go the other anti-skeptic, or I mean the skeptic way, a little too far, where they're so skeptical of everything that they fall into thinking that it's proven that certain pseudoscience things don't exist. Where in some of these cases, such as whether, you know, aliens have ever visited near the planet Earth in the history of the universe, we, you know, don't have a way of disproving the pseudoscience. The pseudoscience part is believing that we have proof for it. Other things like homeopathic remedies, we do have disproofs for. So there's examples of that too. But if you're a scientist, remember that there's a lot of questions about the universe. We're going to keep updating the universe model all the time. It gets updated all the time. That's how science works. You throw together your best guesses and they improve over time. You keep updating your hypotheses and tweaking them and they get better and better. So these ones are kind of cool, just about the graphs again. Look at these little like stage areas. When we had it at 0, it seemed like, oh no, not 0. There was one level where it seemed like there was just one stage maybe, or maybe I was just zoomed at the wrong scale. But yeah, you see like these little stage areas. This is, where did they look extra stage-like? There was this one zone where it looked like a little arena or something. Maybe that was a previous version of the equation before I tweaked it too much. But yeah, like here, look. It's like this whole little arena. Doesn't this look like where you'd have like a gladiator fight or something? Like here are the gladiators, here's like the lower ring of seats, and here's the upper ring of seats. So you got, or like a good concert hall. Yeah, look at this concert hall. That's a perfect place to perform. Although I don't know if concert halls usually have that many people behind the band. But so with a few more edits right here, this already got kind of complicated. So let's shorten the room by turning the pluses to timeses, because timeses can just be the things next to each other. And, ooh, this is a maze-like one. I love the maze-like ones. So look, this is an easy maze, but you can go down here. Or maybe it's an easy maze. Maybe it's harder than... You got to be zoomed in to make sure you're actually seeing it. Does this ever cross over? Oh, we get to this new, like, zone. Look at these zones that connect. That's so cool. We can, like, wander from one to the other. This is like the giant gladiator. This is like a labyrinth, you know, where the gladiators who lost get banished to. Whoever lost that last gladiator fight gets sent here. So... you also get these checkerboard-like little zones. Do those have the same size as we go over here, or do the zones grow, perhaps? Yeah, if we look over here, we have larger zones. I think they slowly expand. It's sort of hard to tell. Maybe not. If we zoom out, here's one of the cases where it's not showing the date. Oh, we got this guy called Bernard, I think is right there. Yeah, I think that's Bernard. So he's a particular glitch. He's so particular, he's been named by people who use Desmos. I'm not making up this name. It is a used name by Desmosers. This guy's called Bernard. And I think you can't fully see all of him. I have this, like, it's a little off screen. So there's a little more. Wait, let's remove that. Oh, he moved over. So yeah. If we zoom out enough, maybe we'll see just Bernard. Yeah, okay, we're getting a really clear Bernard right there. Nope, lost. Okay, yeah, you see that fuzzy part? I'm blocking him. It's Bernard. So yeah, that, for some reason, this would be I need to look into this. I read about it once. I read the reason for it, and it, like, I forget it. I need to reread the reason for why specifically Bernard shows up, but there's a reason why the glitch often looks like this one shape. But before we got Bernard, I wanted to show that there was these other types of patterned glitch. Oh no, I'm going out way too far. I need to go back in. There was another level of patterned glitches here. This wasn't the one that I was thinking of originally, but it's an example of something I mentioned where even at times where it's like way too glitchy to be able to understand it, sometimes the glitches look really neat and maybe give us info about, like, which parts of the graph were harder for it to calibrate. And if we look over here, the glitchiness is that, like, the center of these arenas have a lot of trouble. Like, the checkerboardy parts are doing okay. But when I move over here, each arena is like, whoa. And some of them glitch to show their stuff. Some of them are, like, empty until they're like, until they're in the right spot to glitch to show it or something. But then if you zoom in, you see that's because those have the more fractally like little bits. Although maybe not fractally like. Maybe it's just yeah, I guess just smaller amounts just mess up when you're far enough out. As I said, it's partially an issue with their, ability to compute a crazy thing like this, and partially their ability, regardless of computation, to display something that has a lot of small things where if you filled in a line for everything, sometimes it gets too clogged. Okay, where was 0, 0? There we go. So 0, 0, interestingly, is not in the middle of an arena or a checkerboard. It's at a pretty arbitrary looking spot. Now, I like this one, so let's fiddle around with that. This one was when we had ceilings, so I'm going to turn these into floors or rounds to begin. Floor and ceiling there messed everything up. So would ceiling over floor do the same? Or this is floor over floor. So here's ceiling over floor. And yeah, the ceiling is over the floor. That is the right direction to build the house. And how about round? Okay. With how confusing the term round is and how it makes things non-round, I wouldn't be surprised if math and English collaborated some secret plot to have, like, floor have been called ceiling and ceiling have been called floor or something. I need to sometime compile all the examples of things that were poorly named in mathematics mixed with English. It's just such... it's not a big problem if people are open to editing and evolving terms. Like, there's no problem with the term being a thing that somebody used for some paper. Maybe it caught on, maybe it didn't. Should be survival of the fittest. The best nicknames should stick, you know? But it's not survival of the fittest. When a name gets into the dictionary or into the mathematical language, people are like, that's the name forever. I've mentioned to people casually, like, what do you think about if we cut a few letters out of the English alphabet? And they look at me like it's blasphemy. Like, what? No, there are 26 letters. You can't change that. It would destroy all the schooling systems to change that. And it's like, folks, J was not in the alphabet 200 or 300 years ago. 200 or 300 years ago, there was not 26 letters in the alphabet. You know, within the last 500 years, there was a different letter at the end. The ampersand was in the alphabet at the end. There have been times in the past where TH had a letter in the alphabet, where tons of other letters were in, other ones weren't in and got added. J and W are pretty new. And it's like, really? We're going to let it evolve and just arbitrarily at this point, I guess at the time like globalization and the internet began, when languages became more documented across many continents, just stick there forever? No. We got to keep letting stuff evolve. Language must evolve. It works with slang. Slang evolves along with the times. Mathematics language and the English language for terms for things needs to be a little more like slang. It needs to let itself evolve a little more. Survival of the fittest among the nicknames. So, for example, we're just like stuck on calling imaginary numbers. And like, there's so many confusing things that describe multiple things in math. There's like congruent, means like 5 different things in math. So, and like some of them make sense, like they're like similar to each other, so they make sense that they're, you know, they both describe it. Maybe it's like a geometric thing and then an algebraic thing, but they're kind of similar. Other ones are just like, let's just call it congruent because that's a name. No care for the fact that it's already used to describe many things. And oh boy, there's perfect numbers and perfect powers. It's like, you're really going to call 2 of the more common number theory concepts perfect and make us use 2 words to make, I can't just say, okay, we're talking about the perfect ones. You know, I have to say perfect number or perfect power. And there's better names for perfect powers anyway that I'll describe in the future the better ways we should call things like perfect powers. Now, since I've been mentioning this is sort of cool, a lot of different moons. Look, it's sort of like a bunch of different moon shapes, and then they clump together. And then they turn into someone mooning you. So, here, got some interesting different zones. This looks like, the last one was a gladiator arena. This is like in the middle of some strange ceremony, you know, in the middle of some strange cults hall. You go into the middle of right there to, you know, worship Threven things. So, although this is more like the chamber for the doubly even society, I'm seeing, you know, we got our classic 4 different ways things are. So, anyway, since I've been mentioning some other projects I've been working on, I have been inventing a lot of cool types of things. And I'm not going to spoil the main ones that I know are like, I'm not going to spoil any specific things that I've invented that will show up in an episode, but there will continue to be more and more of the cooler things I've discovered. I had saved in my notes for a while, many of them. And at this point, I'm like, oh man, some of these ideas I've had saving in my notes for a year or two. I need to finish them up. Some of them were saving because they needed help from people like programmers to test data or stuff. So I am working with people to finish some of those up. But while I won't spoil any of the very specific things, I will say my newest side project is looking at the representations in the realm of basic bases. And there is so many underrated mysteries within what digits occur throughout a number's representations in the different bases. Each number has a finite set. And I just need to mention this real quick because I've been like obsessing with it today. This is so underrated. The different traits that a given number has among the finite list of distinct representations it has in the basic bases. It's finite distinct representations because these are all non-distinct. We get to a point for a given number where it's always the single digit character that represents that amount as a single digit character, like 5 there, or like A is what we're calling the number for 10 down here. So if we look at just the distinct representations of a number, the number we know as 10, for example, has these distinct representations. And there are so many cool patterns in here. So this is one of those things that within my notes, I'm like, how am I going to break this into concrete separate episodes? Because I can't just like make a 7-hour episode about all the cool things I've found within that. Or maybe I should just make a 7-hour episode. But I get too perfectionist already about the half-hour episodes. And time to go back to some 10-minute episodes for a minute. The next episode's another 20 or 25-minute one, probably. But after that, back to 10-minute videos for a minute. But so I'm going to break off some digestible separate subtopics out of that. But this is something I have found so many cool patterns in. If anyone wants to create some diagrams of this, the internet is missing more tables like these are just things that should exist. Tables like this. But here we have a number. Here we have a base. And here we have a trait about it. And the trait could be the digit sum, the digit product. I'll give a clue. Digit sums and products are related to the next main episode I'll be putting out. But outside of that, you could have things like how many of a given digit did it have? Or how many distinct digits did it have? Or how many distinct digits did it have out of the total amount possible, which would measure pandigitalness? How many of the same digit? What was the biggest repeating thing? And when we look at what these actually mean, they tell us so much about numbers. Because, like, the fact that here, base 10, the number 9, looks like 1001 and looks like 1000 there. These representations together are like one way of describing the fact that 8 and 9 are neighboring perfect powers. Because here we can see that 9 ends in a double 0 in base 3. That means it is divisible by 3 squared. And in fact, the fact that it is 100, the numbers that are 100, as I went into in an episode a while ago that some people may not have seen, are the square numbers. There are some that don't fit. If it's too small of a base, you don't always have room. But on the big scale, as you go down, square numbers with enough room, you know, like whereas the room gets cut off at 1. 1 does not look like that in any base, but it's technically a square number. But from square numbers larger than 1, they look like 100 in some base. So here we see 100 describes 9, but we also see 1001 in binary describes 9. So what do these middle zeros tell us? They tell us that it doesn't take that many powers of 2 added together to make this number. We don't need like one of that power, one of that power, one of that power. We just need one of that power and one of the 0th power, which is 1. 2 to the 0th power is what that spot's worth. This spot is worth 2 to the 3rd power. And so here we can see 2 cubed plus 1 equals 3 squared. And that's just the tip of the iceberg of the type of things you can see in these representations. For anyone who wants to look into this on your own, look into, this is the number 12 right here. Wait a minute. Taking off a 0 is like times 2. Taking off another 0 is like another times 2, or removing it would be like divided by 2. Wait a minute, 1, 1 in binary is how we write 3. Wait a minute, 3 times 2 is 12. So you can deconstruct these in so many ways. And as I'm looking at it, I'm finding that the middle zeros are sort of interesting. It's not as obvious of a pattern as ending zeros tell you a lot about this number is a perfect power. If it's 1 followed by a bunch of zeros, or if it's like not a different beginning but ends in a bunch of zeros, it tells you the number is divisible by some really big perfect power or some high power of a number. But if we have like this with 1, 0, 0, 1, that still told us sort of an interesting fact about perfect powers. Like it was much simpler to describe. It breaks down to a simpler polynomial, like which numbers could be described, or what we call a Diophantine equation, because we're looking for integer solutions. Which ones would have a cube plus a 0th powers, which is always 1, add up to a number. So the numbers that look like 1001 that have enough room, because, you know, sometimes like how 1 didn't fit for the squares pattern, don't always have enough room for the tiny first examples. But beyond the first one or two, numbers that look like 1001 are precisely, and I mean, it's the first case of 1001 works like this, but not the first number that would match this. There may be a number that matches this that didn't have room. But if there's room, these are precisely the numbers that are 1 more than a cube. So what about like 1010, like 10? 10, the number we know, you know, R10 is 1010 in binary, which is a fun, I just find that fun. It's 10 to us, but really in binary it's 1010. And in ternary it's 101. It really likes that sort of beginning. But here, what does this tell us? Well, we can see that it's 2. Wait, okay, I'm not going to go into all of the really cool details of how you can see this 2 times 5. But when you look, if you look at it, what it takes to double something like this, see what happens when you take 101 times a 2-digit thing, like 101 times that 2-digit thing. You can like factorize these, and because they represent polynomials, so I knew they could be factorized in what they represent as the number in terms of polynomials, but you can like factor them by looking at the representation in some crazy ways. So that's my current obsession. But as I said, if you want to hear about any of my other obsessions, you can always see if I'm available to chat on the Discord. Or if you want to consider like helping with any technological things, you could always message me about joining a group I have been working on. If you are someone who has messaged me through email and I have not replied yet, I'm sorry, I'm still catching up on those. I sort of got really anxious about being late about replying to a bunch of stuff. And so sometimes I will just like hide from that because I'm anxious about being late of certain things. And I'm just not good at replying to digital things like emails and stuff. I'm a lot better face to face with people, which is difficult because I don't know like any of my, you know, viewers or that type of potential collaborator face to face. But I'm more natural at communication face to face. I don't like use texting and email and stuff that much. I'm pretty old fashioned with technology. So anyway, that's enough of the rant about this, but this will show up the ways I've figured out that these patterns can be described as alternate ways of describing things like factorizations and things like that, as well as, the reason I brought this up is more to say, if anyone wants to make tables that count things like how many of each digit there is, I feel like those are things that should exist online, because it's really like there's a few sequences on the OEIS related to how many zeros are in the middle, but not enough sequences. There's a lot of open questions and stuff. Like the zeros in the middle are notable. They mean numbers are simpler in terms of sums of a given perfect power or given powers of a starting number. But then the other ones that are more complicated are interesting too. Those are like the pan-digital ones are like extra complicated. So this is something that will show up in more bases in the future. And what I call this, originally I called this the realm of basic bases, which is still sort of my main nickname, but since I like alliteration, I also like to think of this as the just realm of representations. And remember, base 1 askers, there's always someone out, I haven't seen it in the chat, I haven't looked, but there's always someone out there who's like, well, what about base 1? No, base 1 doesn't get to be here. We need to use bijective base 1 if we want it to even work at describing numbers, and these are not bijective bases. So we're not going to throw on a different type of base just to be able to have base 1. Base 1 in the form that these are in does not work at creating any number larger than 0. That's because they all have digits from 0 to 1 less than the base. So, base 1 would need 2 digits for base 1 and just doesn't work with the patterns, even apart from the fact that all of powers of 1 are all the same. So every spot would be worth the same. So like the number 1, 0 would be the same as the number 1, would be the same as the number 1, 0, 0. There's several ways why normal base 1 doesn't work. Now, back to the graphs, because that was sort of a side tangent, but I think that's something that my viewers who enjoy numbers should look at something like that more. That one is called, this is the link of this one because it's a good one so far. This is, a decent one I found online. But there's so many more tables that could be made of other types of things related to this, but even just looking at this gets you so much more in touch with what numbers actually are. Like, not the digits that we expect numbers to have, what really are all of the common simple forms a number could have. And so, ooh boy, if you like number theory, stare at this sometime. Very underrated. It won't be hard to figure out an open question about this that you could test. There's things about this that literally only 1,000 numbers have been tested. If you go on the OEIS, anyone who likes programming, you can find sequences that you could be the first person to discover something just by testing the 1001th term. So, yeah, zeros in the middle of numbers. Mathematicians, alert, alert. Something important going on there. Think more about it. I'll explain more what I mean about that in an actual video sometime. That was a long tangent. Also, unfortunately, I hate to say, not only is it getting kind of late, it's 11 p.m. here, but I just hit a low battery warning, and I do not have my extension cord to plug in the computer out here. So that is going to be the 10 minutes left, or 5 to 10 minutes left warning. So to anyone, I will check the chat before I log off. To anybody who happens to be watching live who has any questions or anything, feel free to ask, and I will check the chat before the computer dies, but we're at 8%. So fiddling around with this 1 or 2 more times. This one is really cool. This one I was just like left on while I was chatting because it was cool enough. It was doing the job itself. I didn't even need to describe this for it to be cool. But now I'm going to describe it. Now we get these lines of balls. Morph it just a little bit. The balls form these pockets. And in between these square-like pockets, we get these strange little arenas of like moons. Then, if we go a little further, well, let's see what numbers they're actually at. 0 does nothing. 0.1 does this. They formed these little clusters. It's really interesting. What are these clusters? Like, what is determining the size of this cluster? It cuts off at like 32 or 33 or something. It's like a 33 by 33-ish pattern. Like, that's repeating. So that must be something along the lines of like pi cubed rounded down or something. Not literally that, but pi is often involved when we have the trig things. Although round might be making things a little weird. Let's see. This one was neat, so I want to see what it would do without the rounds, but it might be boring without the rounds. Ooh, not really boring. Let's see if it morphs. Yeah, no, not boring. Not boring at all. This is a good one. What's it? So this is cosine of x times sine of ay is greater than or equal to cosine of y times sine of ax. So it's really just this same thing copied right there. Same thing twice, except with the x and y flipped. So this is another pretty simple, and let me check if it's necessary for these to be cosine as opposed to sine. Sine, is that also interesting in a different way? So this is also another really simple formula that is like almost symmetrical. We have the exact same thing but with x and y flipped, and a is the same on each side. Now, to make it a little less symmetrical for fun, here's what we're going to try. A plus 0.5 times y. So that's going to like smush things in a sort of weird way. So, yeah, now it's like a little more off.
that would be good if you're trying to make a maze, to make it, the almost symmetry might be good for how I was saying people should try and make mazes that have an equation. So also, if you like need to design some wallpaper for your house, just use one of these. There's so many like beautiful patterns. Don't you want to be able to say like my wallpaper is this particular really simple equation? So here's an interesting thing to note. When we're at 0.5, it gets really square. And that's weirdly, it's like a weird value because we have half of x there. And here it did go up to 1 of y, but we still have exactly half of x. And before, when we had half of one of them, I recall the squares usually come when we're at 0. Like even if we're at 1 here, I guess does have a type of square as well. So it makes sense. Now it's one of these is 1 and one's 1.5. Now if I'm at 1.5, which makes one of, because I have the 0.5, it's one of these is 1.5 and one's 2. We get this thing with these ovals. Okay, there's so many cool states here. I do need to remove the weird difference and just look at all these states. So this is like, and let me write this as simple as we can. Are they going to let me do that? Nah, they're going to make me need parentheses. So yeah, it's that times the flip. Now this is when a is 1.5. But look at all these different states in the same graph. So here, oh my god, there's a whole realm between a missing 0 and a missing 1. If you just, and that's crazy because sometimes I go up in steps that are just 1. Imagine if my step was just 1. Look at how much I would have missed. I'm like, okay, nothing. Or is it? When we do step 0.01, look at this. Wait, no, we have to be between 0 and 1. All of this was hiding between 0 and 1. So that reminds me of how when we do equal, here we didn't lose all of it, but sometimes we lose a lot of the depth when we do equal. Here we still have some cool stuff. But, and in a way, we should sometimes pause to look at the equal version because this is sort of beautiful in an even simpler way that this is like a certain type of equality as opposed to a type of inequality, and wow. But mathematically, that's almost more beautiful, but visually, this is certainly more beautiful. And sometimes we need the inequality, as I showed earlier in this stream, to show a gap. Sometimes there's like waviness that you can't see with the equality part. And here we can see that if I have the inequality and I just went steps of 1, I would miss this entire realm. All of these steps are between 0 and 1. In fact, I want to just see the world between 0 and 1. Here is the whole world from the blank 0 to the blank 1. That is such a deep, dense world to be just hiding between two missing integers where it doesn't work at the integers. And it gets close to this on that end, and on this end, it gets close to that. So that was just between 0 and 1, so let's go back to -10 to 10. And after 1, we get these whole other realms. Does it vanish at any other integers? No. It looks like whoa, oh no, I hate when this happens. It zooms in the wrong way. It like zooms in on the computer zooming in, not on the Desmos doing it. And then that's always hard to get out of. So here, okay, it's going kind of slow. Is that the battery? Okay, yeah, we're at 4%. It's probably not going to like the Desmos as I get to really low battery. So I should really check the comments in case this ends up dying anytime soon. And we have some interesting thoughts about various things that I'll check out. To some people who have mentioned things like certain people's work on a particular topic or certain people's writings or whatever, or videos. To the ones I haven't seen, I will try and check those out sometime. I always love suggestions for cool videos or books or articles or whatever, or concepts. And we have a note from someone about the number representations. So a number can have an arbitrarily large but not infinite amount of representations. Well, remember you need the word distinct there, because if we count all of the base representations, there's an infinite amount of bases for a given number that it can be expressed in. So we could say it has an infinite amount of representations, but that all the ones after a point are the same single digit character. So you got to make sure to use the word distinct in there, and then totally yup. And to any other ones I wasn't able to answer, sorry, but thank you everyone for leaving your thoughts, and I will look through those more on my own later. Right now I just have like 3% or something, 4%, so we need to wrap up on the sooner end. And there was a lot of other stuff I didn't get to of various things I wanted to discuss, but probably you folks got the point that I've been working on a lot of cool things, but various factors of life have been quite crazy. And so I have tried my best to be able to speed up the process of releases and improve the quality of certain things. And sometimes I haven't been able to fully implement that, at least on like this bonus channel. Haven't been doing that much on in the past few months on this bonus channel, but I intend to do a lot more because I'm getting further and further ahead in how many notes I have compared to which ones have gotten into videos yet. And another weird thing I've been perfectionist with is like wanting all of my videos to involve a personal discovery or like some new extension to the concept that hasn't been explored before or something. And so I got to remind myself, like, okay, I also have a lot of notes about just like classic math things that I've researched that I forget, like, other people don't know about. There's tons of cool, like, paradoxes or statistical anomalies or like puzzles that have like a strange way of solving them, or, you know, type families of numbers, open questions in math. There's a lot of popular stuff that I have taken a lot of notes on that I have to remind myself. And by popular, I don't mean like that you know about it. A lot of the stuff you probably don't know about. I just mean like I didn't invent it myself. And so I got to remind myself, not all of my videos have to be something I invented myself. So I'll make more of those sorts of videos too, about like my take on some classic problems as well. And by classic, I mean the underrated ones, but classic in terms of like people who are obsessed with number theory or stuff. Now, this one is having a lot of trouble. Whenever I try and zoom in, it's doing that crazy thing. It's not like in the Desmos. Sorry, Desmos, we're going back to table of bases. And we're going to wrap up here, but thank you all so much for joining me. There's a lot more I could say, but I'll save it for another live video in the future. And there will be more non-live other things coming on this channel. I'm going to be doing live streams a little less than I used to, but trying to release even more bonus videos and shorts, just because live streams are fun, but often I'll like sort of feel like I used up an idea within it and didn't present it as good as I could have in an edited video. So I'm going to lean a little more toward putting out a bunch of bonus videos and shorts on this channel, but there will be live streams here and there as well. So make sure that you're definitely tuned into my other main combo class channel. Hopefully within the next few days or so, there will be a really cool episode coming on there. And the last few episodes on there, please check out. They are some of the best projects I've ever created in my life. And in general, that is where like my top-notch projects will go. But this channel has a lot of cool plans as well. And I love all of you folks. Thanks for watching. In the links, there is also stuff like the Discord. If you really want to be extra helpful and get some random bonus content, there's links like the Patreon, or on this channel, you can also do a YouTube membership type of supporting. And I'll catch you all in some bonus stuff in the future. Time to put my clover plant somewhere safe where it won't have a giant stick from the tree fall on it. It's been quite windy recently. And there's my little four-leaf clover. I can't believe the four-leaf clover itself is still thriving. I planted this weeks ago. And like I thought the leaflets would have swapped. Like these ones would have died and new ones would be there. But I guess, you know, this one is still holding on as the new leaflets emerge. This one's still there a little while. And we're going to grow some crazy ones. I'm going to make it grow a 5-leaf clover or 4-leaf. I'll pick it, I'll isolate it, I'll make a 5-leaf, I'll pick it, I'll isolate it, I'll make a 6-leaf. Maybe. We'll see. Something cool like that could happen. So thank you all for joining me. I think the battery's literally about to die, and I'm worried that if it dies before I click stop streaming, it'll be a live stream. That happened once. It was stuck in the stream and I couldn't stop it. So I'm going to stop it right now. Okay, that was terrible. I had so much anxiety. It was literally stuck in the stream. Like it was still streaming, but it wasn't giving a signal. So it looked like there was a stream, but then anyone who clicked the stream just got nothing. And I imagine that made like a bunch of people unsubscribe from my channel, because for like hours there was like something that would show up on your homepage, and if you click it, it's nothing. Still, the stream's nothing. And I couldn't get there was a power outage that time, so I literally could not get back in to turn off the thing. But maybe if the battery dies